Nested loops are loops within loops. They are used when you need to perform repetitive tasks that have multiple levels of iteration. Nested loops are often used when working with multidimensional data structures or when you need to iterate over combinations of elements. A nested loop is a loop inside another loop. This means that one loop is placed within the body of another loop. The inner loop will run its entire course for each iteration of the outer loop. In Lua, any loop construct can be used to create nested loops. This includes for, while, and repeat until loops. Here are examples of nested loops using each kind of loop construct, for, while, and repeat until, along with a mixed example. In our scenario, the inner loop j runs twice for each iteration of the outer loop I. So, the inner loop completes its entire cycle, from 1 to 2, 3 times because it's nested within the outer loop. A nested loop is not a distinct type of loop but rather a variation of loops where one loop is contained within another. It involves placing one loop inside another loop, allowing for more intricate and layered repetition in your code. This nesting creates a hierarchy of looping structures, enabling you to tackle more complex tasks by breaking them down into smaller, manageable steps. Here's some common scenarios where nested loops are used. When working with two-dimensional or multidimensional arrays, you may use nested loops to traverse each element in the grid. For operations involving matrices or grids, nested loops help access each element or perform calculations row by row or column by column. When dealing with nested data structures like nested lists or objects, nested loops help access or manipulate elements at different levels of nesting. In algorithms like searching or sorting, nested loops may be used to compare elements in a nested manner, such as in bubble sort or selection sort algorithms. They can be used to generate patterns or sequences that have multiple levels of repetition, such as printing shapes or creating fractals. In password cracking or generation algorithms, nested loops may be used to iterate over different combinations of characters or symbols. Nested loops provide a versatile approach to handle complex data structures and repetitive tasks that involve multiple levels of iteration. Many programming problems, especially those involving nested structures, require the use of nested loops to iterate through various levels of data and perform computations or checks. While nested loops can increase computational overhead, they are often the most efficient way to handle nested data structures and perform operations that depend on multiple levels of iteration. When used judiciously, nested loops can improve code clarity by encapsulating logic related to nested structures, making the code easier to understand and maintain. Understanding how to work with nested loops is a fundamental skill for programmers, as it teaches logical thinking and problem-solving strategies applicable to a wide range of scenarios. They provide a powerful mechanism for navigating through multidimensional data and executing tasks at different levels of granularity, making them an indispensable tool for any programmer.